Hello guys, welcome back to STEM Trainers. In the previous video, we have seen inverse of a function. So basically, if a function fx is given, how to find its inverse function. And second thing we saw is that domain of f is range of f inverse and range of f is domain of f inverse. So basically, we have solved a couple of questions on these concepts. Now let's move forward. Now, if a function and its inverse are there, then you must know these couple of things. First thing is f of f inverse x is equal to f inverse of fx is always equal to x. So let me give you one example on this. Let's take a very simple function. Okay, let's take a straight line 2x plus 3, let's say. So this is my fx. What will be its inverse? We know that we will find the value of x, that is y minus 3 over 2. Then we interchange x and y. So y will be x minus 3 over 2. Correct? So this is my f inverse x. Now what they are saying is, if you have a function and its inverse, if they both exist, then if you try to find f of f inverse x, so what will be? So f of inverse is x minus 3 over 2. So basically f of x minus 3 over 2 will be equal to what? So this is my fx. So instead of x, you substitute x minus 3 over 2. And you can see that this will be nothing but x minus 3 plus 3. So it will get cancelled. So you will get x only. So that is what they are saying. F of f inverse x, or you can take f inverse of fx. This value will always be equal to x only. If f and f inverse are inverse functions of each other. Okay, so this is very important. You must remember this. This is helpful in some parts of a question. Second thing is, the graphs of fx and f inverse x are reflections of each other in the line y equal to x. So if you draw the line y equal to x, you draw fx and f inverse x on the same graph, then you will see that if you take the reflection of fx in y equal to x, then you will get f inverse x. Or if you take the reflection of f inverse x in the line y equal to x, you will get fx. So this is also very important. We will see its use and how the question they will ask. Now one more thing, one last point that you should know is, for a inverse function to exist, the function must be 1, 1. Actually, there is one other condition, but that is not in our curriculum. But you must know this only. So if inverse function exists, it means fx, function fx is 1, 1. And some other condition is also there, but that is not in our curriculum. Okay, for now you can just remember this. So if inverse exists, function is 1, 1. That is, the mapping is 1, 1. Okay, so based on these three concepts, let's try some questions. First question. A function is defined by fx equal to x square minus 3 and x is all real numbers and greater than equal to 0. State the range of fx. Find fx, state its domain range, sketch, solve. Okay, this is a very good question. This covers most of the difficult parts of a question. So let's try this. First question is, state the range of fx. Okay. Now, you can see that fx equal to x square minus 3. Now, what is this x square minus 3? We know it's a quadratic, right? So its graph is a parabola. And because coefficient of x square is positive, as we discussed in the graph of quadratic video, coefficient of x square is positive, so it will be something like this, right? And what will be its x? So you must have studied this, or turning point. If you differentiate this, you get 2x, right? So 2x equal to 0. So x equal to 0 is the turning point. So 0 comma minus 3. right? If you draw the graph, you will have something like this. Now, if x is greater than equal to 0, it means we are concerned only about the right part of the graph. So what is my range here? -3 to infinity, right? So from -3 onwards, it will have the range. I hope it's clear. So they're asking for range of fx. So we can say that range of fx will be y belongs to R, where y is greater than equal to -3. I hope it's clear. So this is we are talking in terms of graph, right? So what else you can do here is, if you don't want to solve this question using the graph, you can just simply say at x equal to 0, what's happening? What's the value? -3. What happens when you increase the value of x from 0? This value x square -3 will start to increase, right? So minimum value is -3, and afterwards it will start increasing. So what's my range? Y is greater than equal to -3. You can say this also, or whatever you feel like, or whatever you are comfortable with. Let's go for B part. Find the inverse. So what do we do in inverse? We take fx as y, that is y is equal to x square -3. Then what we do is we try to find the value of x. So what I will get from here is y plus 3 equals x square, and it implies my x value will be equal to square root of y plus 3. Correct? And actually we know this, whenever you have a square and you are taking a square root, so you will have a plus and minus sign here, right? So basically, let me write here separately, you will get two values of x. Either x is square root of y plus 3, or it is minus times square root of y plus 3. But you remember this also, inverse of a function is always unique. So you can't get two answers. You must get only one answer. And second thing is, you know that x is greater than equal to 0, right? So x can't be minus times this, because this number is less than 0. So we can simply reject this and say that my inverse is square root of x plus 3. So from this, we found the value of x, then interchange x and y. Then we get y is equal to square root of x plus 3. And this is my nothing but f inverse x. I hope it's clear. So this rejection part is very important. Okay, so you will get this in lot of questions. So you must know how to reject this. Always remember, inverse of a function is always unique. You can't have two answers. Okay, so that's for B part. Okay, they are saying state its domain and range. Okay, so we discussed this in last lecture also. Domain of f inverse x is actually range of fx that we already found. I think range of fx is this, y is greater than equal to -3. So what's my answer? X is greater than equal to -3, and x is a real number. So this is my domain of fx. Now they are asking for range of f inverse x. So range of f inverse x is nothing but domain of fx. So this is the domain of fx. So my range will become y is greater than equal to 0 and y is a real number. I hope it's clear. We discussed this in last class also. Okay, now next part is, this is important. Sketch the graph of fx, f inverse x and y equal to x on the same graph. Okay, now this is what we are talking about. That fx and f inverse x are reflection of each other. Let's see. So let's draw the graph. Okay, so y equal to x we know is a straight line passing through region. So this is nothing but my we need it at 45. Okay, Now it's better. Okay, so this is my line. Let's say y equal to x. Second is, now what is my fx? Fx is x square minus 3 and x is greater than equal to 0. We know that x square minus 3 is a quadratic. We discussed here also, right? So let's draw the graph. So at 0, its value is minus 3. Let's say this is minus 3, 0 comma minus 3. And after that, it will increase. So it will go like this, right? This is my fx graph. Now, what's my inverse graph now? F inverse x is root of x plus 3, right? So how do you draw this graph? You can see that x equal to minus 3, its value is 0, right? So at minus 3, its value is 0. So 0 minus 3 comma 0, right? And after that, what will happen? If you start increasing the x value, after that, because the domain is x is greater than equal to minus 3, so you don't have to draw the graph before minus 3. So graph will only be after minus 3. Anyways, so at minus 3, its value is 0. And if you increase the value of x from minus 3, it will start to increase, right? So it will be something like this. Okay, this is a square root graph. We have a quadratic graph, we have a cubic graph, and we have a square root graph also. So this is a square root graph. So this is my y equals f inverse x graph. Okay, let's first see this. Now you can notice that y equal to x acts as a mirror for fx and f inverse x. That is, fx is reflection in the line y equal to x for f inverse x, and similarly reflection of f inverse x in y equal to x is fx. You can see this, right? So that's one thing. Actually, in C part, they are only asking for graph. So we have already sketched it, but I hope you understand this. Now this D part is very important. In D part, they say solve the equation fx equal to f inverse x. Okay. So how do you solve? Basically, you have fx, you have f inverse x, just equate them, you will get some answer, right? So if you try to equate fx and f inverse x, so fx is this, f inverse x is this. Now you can see this, if you square this, because we have to eliminate the square root, right? So this is my fx and this is my f inverse x. If you try to solve this, then you will have some problems. Why? Because it will become power 4 equation or power 4 polynomial. It will be very difficult to solve, correct? So what we generally do is, now we use this concept that if fx and f inverse x are intersecting, then they will intersect on y equal to x line. Now this is important. As you can see also, where are fx and f inverse x intersecting? On the line y equal to x. Correct? So that's the trick or logic we are going to use. So if you want to solve fx equal to f inverse x, so you can simply solve either fx equal to x, or you can solve f inverse x equal to x. So you have two options. Actually, you have three options. You can solve this directly if it's possible. If not, you can try to solve this, or you can try to solve this. So this is very important. Most of the students don't know this. Okay, so let's try to solve this now. So let's try to solve fx equal to x. So what is my fx? X square minus 3. So let's try to solve this. So this will be a quadratic. Minus x minus 3 equals to 0. So if you solve this using quadratic formula, I don't think you can have factors. No, minus 3, no. So this will be 1 plus minus square root of b square minus 4ac. So b square minus 4ac means minus 3 minus 4 is 12 by 2. So you will get x value as 1 plus square root of 13 over 2. and second value you will get 1 minus square root of 13 over 2. Okay, now as you can see from the graph that there is only one point of intersection, and we got actually 2 points of intersection. And second thing is, this value is something positive, right? 1 plus square root of 13. This is something which is a negative number. And you can see that they are intersecting only at some positive number. So actually, you can easily reject this answer. So actually, your answer is solution for fx equal to x or fx equal to f inverse x is 1 plus root of 13 over 2. I hope you are clear with this. Okay, so these things are very important. How to solve, which equations to take, how to reject the answer. I hope it's clear. Okay, let's move on to the second question. Now again, this is also a very good question based on inverse functions. So let's try to understand this. And a lot of times these questions are generally asked in your exams. Okay, the function fx is defined by fx equal to x square plus 4x plus 9, where x belongs to R and x is greater than a, where a is some constant. Okay. Next is state the least value of a for which f inverse x exists. Second, find f inverse x and state its domain. Okay. Now, first thing, they are saying f inverse x exists. And I think we talked about this. So inverse of a function exists if the mapping is 1, 1. So we have to see, this is actually nothing but a quadratic, right? Fx equal to x square plus 4x plus 9. So we have to see when will this quadratic be 1, 1 mapping. So let's first draw the graph of this. I hope everyone knows how to draw the graph of this. So let me draw the graph of x square plus 4x plus 9. We discussed this. There is a separate video I made for drawing of graphs. So what we generally do is we find the turning point, and then we find how many roots are there, and then we find where it intersects. So y axis, etc., etc. So I am not going into detail. I am simply going to draw this. Now why is that is, if you don't know how to draw the quadratic graph, you can watch that video. I think it has 2-3 parts. It is explained properly in 2-3 videos. Okay, so let's draw this graph. So this is actually nothing but, if you make a complete the square of this, you will get x plus 2. I have made a special video for completing the square also. If you are not comfortable with this, you can go and watch that video also. Okay, so you will get y equals x plus 2 whole square plus 5. So minus 2, its value is 5. And it is intersecting this at 9. So this will be something like this. Okay, so I have my graph now. This point is minus 2, 5. This point actually we don't need, but this is 0, 9. Okay, so this is my graph now. Now you can see that for 1, 1 mapping, what should happen is, if you draw the horizontal lines, it should intersect the curve or the graph at only one point. Or you can say at maximum 1 point, right? So if you draw a horizontal line like this, you can see that it will intersect in 2 points. So this mapping will not be 1, 1. So what we should do is, simply if you take only the left part or the right part, then what will happen is the mapping will be 1, 1. You can take either the left or the right. So that's the logic here. Then the mapping will be 1, 1. Now, one more thing, because they have given x is greater than a. Now we know that if you want to go for x greater than, then you have to go for the right part, right? Greater value is on the right, correct? In the x-axis. So obviously it means we have to take the right part. I hope you understand this, why I have not taken the left part. Because at left part we have x is less than. So that's why we need greater than. So that's why I have taken the right part. Second thing is, now what's the value of a? So for example, if you take any part of the graph after minus 2, you will have a 1, 1 mapping. But they are asking for the least value of A. So we have to go for the smallest. The smallest means you have to go towards the left. So what's the smallest value of A? As you can see, this lowest point, turning point is minus 2. So this is very important. So that's why I can say that least value of A is minus 2. So there are 2, 3 logic here. First is, we can take left part, right part. Second is, from right part, what's the least value of A? Obviously, if you take A as 5, then also this will be a 1, 1 mapping and inverse will exist. But 5 is not the least value. The least value is minus 2. I hope everyone understands this. Next is also important. You have to find the inverse and state its domain. Okay. So inverse we know. So this is my y value, x plus 2 whole square plus 5. So from this we need to find the x value. So y plus 5 will be equal to x plus 2 whole square. And from this I will get x plus 2 is equal to, again, same thing. When you take square root, always remember, whenever you take square root, you always have to go for plus minus because it's a square equation and you are taking square root on both sides. So you have to take plus minus sign. So we will get 2 answers actually. So x will be equal to, one answer is minus 2 plus root of y plus 5. And second answer is minus 2 minus root of y plus 5. Again, same logic we will use. Inverse is always unique. You can't have 2 answers. So which answer we should take? So for that we have to think. Okay, we got here x as greater than minus 2, right? So x should be greater than minus 2. So which gives us greater than minus 2? Now this is less than minus 2 because this is minus 2 minus some number. So obviously you have to reject this. So this answer is accepted. Minus 2 plus root of y plus 5. Now then we will interchange x and y. So my final answer is y is equal to minus 2 plus root of x plus 5, and this will be my f inverse x. I hope everyone understands this. This is important. Next is, we have to find its domain. So domain of f inverse is basically range of fx. And range of fx we already know, right? This is my graph. Range means this value is, what is this value? This value is 5. So from 5 to infinity. So my domain is x is greater than equal to y, it is, oh, it's plus, it's not minus. Okay, my bad. So that's why it was coming out to be wrong. So this is not y plus 5. This is y minus 5. And this will also be y minus 5. No problem. Y minus 5. This is also y minus 5. This is also y minus 5. Okay, no problem. So this is x minus 5. So my domain is, domain of fx is x greater than equal to 5. Now why is that? Because domain of f inverse x is nothing but range of fx. And range of fx is from 5 to infinity. Okay. So that is my answer. I hope everyone is clear about this. So this is how you can use these concepts. Okay. So remember this. These are only 3, 4. If you remember all of these, I think you will get perfect score. Just you might be needing little bit of practice. So thanks for watching STEM Trainers.